Hi there and welcome to the video on quadratic functions. This is section 1 of chapter 2. Our skill objectives for this one are 1, we're going to graph quadratic functions that are in standard form or general form. Number 2, we want to find the equation of a parabola. And the third thing we need to do is solve application problems that involve quadratic functions. Conceptual objectives in this case, number 1, well, the only one, is to recognize characteristics of graphs of quadratic functions. So what we're going to be looking at there in terms of is the behavior, does it open up or down, in terms of the axis of symmetry, identify that, also look at whether or not it has any x-intercepts, and also working with the y-intercept. Before we go on to quadratics, I want to start out by looking at what I call the alphabet soup definition of a polynomial. You're going to see a lot of letters and they all have meaning in the problem, in the definition, but you need to be aware of them and the restraints on them. But you'll see this definition now, and it's also going to make its appearance again in the next section. You can actually see this written out in the book on page 238. Basically what we have is we're going to let n be a non-negative integer. So what that means, it's going to be positive. It could be 0, 1, 2, 3, 4, and so forth. And we're going to let a sub n minus 1, all the way down, down to a sub 2, and a sub 1, and a sub 0. So all those values right there, those are some real numbers. So there's going to be something that shows up on the number line. And the other condition that we have is that a sub n cannot be 0. It can be any other number, just cannot be 0. Okay? And so what we have is the function f of x equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus plus a sub 2 x squared plus a sub 1 x plus a sub 0. This is a polynomial function of degree n, and that a sub n is called the leading coefficient. Let's say that again. In this case, all these coefficients, all these numbers, these a sub n's and so forth, those are all real numbers. N is a non-negative integer. It could be 0, but it's also it could be 1, 2, 3, 4, 5. It could be 10. It can't be anything negative. And that will be a polynomial of degree n. And we classify polynomials based on their degree. So when we talk about a polynomial that might be of degree 0, that's going to be a constant function. That's going to be the constant function that you see from our basic functions that we saw in chapter 1. If it's a polynomial of degree 1, that's going to be a linear function. So it's going to the graph will be some line. And a polynomial of degree 2 is going to be a quadratic. And that's really what we're going to focus on in this video. But please remember this definition and how that works. Now let's get to a definition of a quadratic. And this is going to be a little bit more familiar, a little bit easier to work with. We're going to let a, b, and c, those three, be real numbers where a does not equal 0. Again, that first one cannot be 0. The others could be, but the first one definitely can't. Then the function f of x equals ax squared plus bx plus c is a quadratic function. Okay, that's a very familiar form for that quadratic that you've seen. Also, though, I want you to be aware that there is another form for the quadratic, and we're going to be putting the quadratic into this form. It's called standard form. And in standard form, what we have is f of x is equal to a times the quantity of x minus h squared plus k. The a that you see here is the exact same value as the a you saw in the general form of the quadratic. Those will be equal in either form. For the same, when it's the same parabola. The h and k have special meaning that we're going to be looking at coming up. What we have here graphically for a quadratic is that we're going to deal with a parabola. Now I've given my best attempt to draw two parabolas here. One that opens up, this one here opens up, and this one over here opens down. And the way we go, what we're going to have to do on this, some things that we have to keep in mind is number one, in terms of determining whether or not the parabola opens up or down, that all is based on A. If A is greater than 0, the parabola is going to open up. If A is less than 0, the parabola opens down. Also, when we have the standard form, I want you to notice the h and k here, and those happen to be the coordinates of the vertex. The vertex is an important point when we're working with parabolas, because of the fact that when the parabola opens up, that vertex is going to be a minimum, and when the parabola opens down, our vertex is going to be a maximum. And those are going to be two things. You're going to hear those words a lot, especially in story problems, and you're going to want to be aware of those. And when you hear maximum or minimum, when you're working with a quadratic, right away you should be thinking find the vertex. So when we look at this in that standard form, f of x equals a times the quantity of x minus h squared plus k, the h value is going to be the x coordinate of the vertex. It's also going to be the equation, x equals h, is going to be the equation of that axis of symmetry. The k value is the y coordinate of the vertex. Also notice here that h is going to have the opposite sign. It's so x minus h. So I know the value of h is going to have the opposite sign that I see in the problem. K will have the same sign. Let's take a look. One of the things we're going to be asked to do is graph a parabola. And to do this, we're going to want that parabola in standard form. So what we're going to have to do, the first thing we have to do whenever we're asked to go and graph a parabola is first identify if that parabola opens up or down. And we're going to do that by looking at A. When A is greater than 0, it's going to open up. When A is less than 0 or negative, it's going to open down. And that is the coefficient. Remember, A is the coefficient on x squared. The second thing we want to do is identify that vertex, hk. Third thing, we want to find the y-intercept, okay? And the y-intercept is a point that is going to be on every parabola. Every parabola will have a y-intercept in terms of the functions that we're working with. And to find that y-intercept, we're going to let x equal 0. So that's the third thing we're going to do is identify that y-intercept. Sometimes, besides the vertex, the y-intercept would be the easiest point for you to locate. And so it might be, and if there are no other points that we have that we're looking for, we would just be able to use that, the idea of the axis of symmetry, and the vertex to come up with the graph of that parabola. The fourth thing we have to do is find any x-intercepts by letting y equal 0. Now keep in mind here, it is possible that there are no x-intercepts. Okay, so if there are no x-intercepts, then we know the parabola never crosses the x-axis. And that's okay, we'll have enough information even without the x-intercepts to go and give a decent sketch of this. The x-intercepts though can help out sometimes, if they're nice values. And the last thing we want to do is once we know all these points, we're going to plot the known points that we have and we're going to connect it with a smooth curve. Now keep in mind, once we know whether or not it opens up or down and we know the vertex, we're going to know if we have a maximum or minimum. And we know if it opens up, we know the vertex is going to be the absolute lowest point. So I know I'm not going to go below the vertex. It's going to level off and make a change in direction at the vertex. If the parabola opens down, then the vertex is going to be a maximum. And again, the parabola, as we come closer to the vertex, is going to level off and it's going to change directions at that vertex as well. Let's look at an example here. In this case, we have the equation f of x equals the negative x minus 2 squared minus 4. Okay, so the first thing I do on this one is I need to identify if this opens up or down. In this case, the negative sign out in front here tells me that a is actually equal to -1, and since a is a negative value, I know this parabola is going to open down. Okay. Next thing I need to do is identify the vertex. The vertex we know is hk. Now remember, it's in the standard form, it's going to be a times the quantity of x minus h squared. So notice what's in the h spot is 2. So in this case, h is 2. Remember, it's x minus h. I have a minus 2. So h is going to actually be a positive 2. and then it's going to be a times the quantity of x minus h squared plus k. Well, in this case, what's in that k spot is a minus 4. So I know the vertex the k value is going to be negative 4. So my vertex in this case is at the point 2, negative 4. The third thing I have to do is identify the y-intercept. Y-intercept is always when x equals 0. So you'll see here at this place I've replaced x with 0. And now what I have to do is solve that for y. So it's already y equals. So it's just simplifying everything. So I take 0 minus 2. It gives me the negative of the negative 2 squared minus 4. Well, negative 2 squared is going to be positive 4, but I still have that negative there. So I'm going to get negative 4 minus 4, which equals negative 8. So I know that this parabola is going to cross the y-axis at negative 8. The last thing I want to do is identify any x-intercepts if they do exist. And in this case, what happens, that means I'm going to put the 0 in for y. So I have 0 equals the negative of x minus 2 squared minus 4. So I go through, since I want to solve it for x, I go and add 4 to both sides. And so I get 4 equals the opposite of x minus 2 squared. Multiply both sides by negative 1. I get negative 4 equals x minus 2 squared. Well, we're working with real numbers here. So in this situation right here, there's no real number that when I square it gives me negative 4. So I know this one is not possible. So that tells me right away that this graph, this parabola, is never going to cross the x-axis. Now let's go and graph this. So the first thing I want to do is I'm going to plot the point 2, negative 4, because that's where I have my vertex. So I go to 2 and negative 4, and I'm going to put my dot. That's where the vertex is going to be located. The other thing I know is that it's going to cross at negative 8. So it's going to cross the y-axis at negative 8. So I go down 1, 2, 3, 4, 5, 6, 7, 8. And we know it's going to cross right here at negative 8. Now, the other thing I have on this one is I don't know the any other point, but what I do know is, remember that axis of symmetry. The axis of symmetry is going to be a vertical line that goes through the vertex. But the other thing about that is that I know that if I fold the parabola in half along that axis of symmetry, any point that's on the left of it is going to land directly on another point on the right. So because I know that this parabola crossed at this point at 0, negative 8, and that was moved over to the left 2 units from the axis of symmetry. If I go 2 units to the right of the axis of symmetry, and I go to the same spot at negative 8, so I'll be at negative 4, negative 8, that point right there is also going to be on the parabola. And I do that because of the symmetry relationship that exists, the fact that it is symmetric over that axis, that we have that axis of symmetry there. At this point, now that I have that information, I'm going to use a smooth curve and sketch my parabola. And it's just going to do the best I can with it. And there would be the graph of that particular parabola. Again, notice what happened on this one. I know the vertex right there. That was one of the points I found. I also found that point right there, which is the y-intercept. Because I didn't know any other point, I could use my axis of symmetry and go and take this point and reflect it over the axis of symmetry, and it would get to this point right there. And that point would be a third point on the parabola, and so I could use that to then go and sketch a smooth curve for my parabola. Now what we have to do is look at how do we go through and put the equation into standard form. That's one of the things we're going to have to do on this. And the way we do that is we're going to use completing the square. The one thing that's going to be different though is when we asked you to complete the square before, the first thing I had you do is subtract the 5, that constant term. Get it over to the other side because we needed to make our life a little bit easier, and that 5 was getting in the way. The other thing we had to do is we had to go and get rid of that 2, and we did that by dividing through by 2. Well, we could do that in those other problems because it was equal to 0. Right now, we're not equal to 0. We're equal to f of x. So that process that we did at that point, it's not going to be helpful at this point. Now, some of the ideas are still going to be there that we have to do, but overall, it's going to be we're going to have to tweak our process of completing the square in order to go through and put this into that standard form. The one thing that we're going to do on this is the very first thing is instead of going through, the reason we subtracted 5 before was to get the stuff with x by itself. So the first thing we're going to do is we're just going to go and group everything with x together by putting parentheses around the two things that have an x in them. So you'll notice I just put parentheses around the 2x squared minus 8x. That 5 is still sitting right out there, and that's fine. It's okay by itself. It'll be happy, and we'll deal with that at the end. The other thing we have to do is that I can't complete the square when that coefficient on the x squared is something other than 1. And right now we have a 2. Well, what that means I have to do is I'm going to have to go and pull out a factor of 2. So when I do that, I'll have f of x equals 2 times the quantity of x squared minus 4x. And that plus 5 is still sitting out there. Notice I haven't done anything with that. Okay. Now, at this point, we're ready to complete the square. Now, the one thing that we have to keep in mind on this one is that I can't just add something to the other side because of that f of x. So what I'm going to do is I'm going to do the process that like we did before. So I'll have f of x equals 2 times the quantity of x squared minus 4x. But here's where it's going to be a little bit different. We know that we added, in this case, we would normally go through and we take half of that value and square it. So I would add, in this case, 2 squared. Well, what I'm going to have to do, because when I put something in a problem, I can't just add it in there without compensating for it. I will also subtract 2 squared, which happens to be 4. And all of that is taking place inside the parentheses there. And I'll still have my plus 5 sitting out there by himself. He's happy. So notice what I've done at this point. Right here, I took half of that value, which is half of that is 2, and squared it. And I added that inside, and I've also subtracted. So this right here is, in effect, adding 0 to the problem, which is perfectly fine. I haven't changed the value. Now, the next thing you have to do, and this is the big jump, what you have to do is this minus 4 needs to come out of the parentheses. But the problem we have is that 2. So what happens when I do that? I'm going to get, in this case, I'm going to put in red, f of x equals 2 times the quantity of x squared minus 4x plus that 2 squared. But now it's going to be minus this 2 here has to multiply that 4 too. So it's going to be minus 8. And then we'll still have the plus 5. Okay. Make sure you are comfortable with where that minus 8 came from. You're getting that because this 4 is being multiplied by that 2. So when I take the 2 times the negative 4, that's giving me that negative 8 there. And now at this point, in terms of finish this up, f of x is going to be 2 times the quantity. Well, remember, the only reason we complete the square is because of how it's going to factor. It's going to be 2 times the quantity of x minus 2, that thing squared, and then negative 8 plus 5 is going to be negative 3. At this point, we know a couple of different things. Number one, this opens up because the a value here is something greater than 0. It's positive 2. And the other thing we know is that the vertex is at the point 2, negative 3. So I know this parabola is going to open up, and it's going to go through the point 2, negative 3. Once the parabola is in standard form, and that's going to be the key for us on this when we're working with these, once it's in standard form, then I'm able to go through and do that analysis that we talked about before, identifying the y-intercept, identify if there are any x-intercepts that happen to be nice values. I mean, if they're not going to be nice, I'm not going to necessarily worry about those. I have other points I can use. But I'll do that full analysis, and then I could make a sketch of the particular parabola. Another thing they're going to ask you to do is they're going to ask you to find the equation of a parabola through a particular point. So in this case, I have a vertex. The vertex is at, in this case, negative 2, 3, and it's going to go through the point negative 4, negative 5. Well, to go and do this particular problem, what I'm going to do is use that standard form that we had before. So f of x equals a times the quantity of x minus h, that quantity squared, plus k. And what I'm going to do is I'm going to plug in what I know in this case right now, the vertex. Okay, and the vertex in this case, h is negative 2. So I'm going to get f of x equals a times the quantity. When I put negative 2 in for h, it's going to be x plus 2, that quantity squared, and k is 3, so I'll get plus 3. The other thing you need to remember on this is remember that f of x would also be y. So I can think of that as y equals a times the quantity of x plus 2, that quantity squared, plus 3. And now, really, the key to this problem is going to be to find out what a is. I've got to identify what a is. Once I know a, then I have the equation of the parabola. I'll just plug that a value in back into at this point right here. I'll identify a, and then I'll come back to this and put that value in, and that will be the equation of my parabola. The thing is, though, I have to find a. And to do that, I'm going to use this other point that I have. So I'm going to plug negative 4 in for x, and I'm going to plug negative 5 in for y. And so when I do that, what I'll have will be negative 5 equals a times, it's going to be negative 4 plus 2, that thing squared, plus 3. So simplifying that, I get negative 5 equals, well, negative 4 plus 2, that's going to be negative 2, but when I square it, that's going to give me 4, so it's going to be 4a plus 3. Subtracting 3 from both sides, I will get that negative 8 is equal to 4a. Dividing by 4, I get that a is equal to negative 2. And so, remember, coming back up to here, this point, I'm going to replace that a with the value I've just found, negative 2. And what I'm going to get then is that the equation of this parabola is going to be f of x equals negative 2 times x plus 2, that quantity squared, plus 3. That would be the equation of the parabola that has a vertex at negative 2, 3 and goes to the point negative 4, 5. Now, the next thing we have is application problems. And in the interest of your time and mine, because I was looking at this and the amount of material that we have here, that it's going to require doing a couple of examples of other types of problems in class. So we'll finish up some of this in class as well. So what I'm going to do is just kind of give you the basics in terms of the application problems. And really what it comes down to is in the application problems when you're working with quadratics, what you're going to hear is really you're going to hear basically 3 common questions. Number 1, what's the maximum or the minimum of the whatever the value that's being modeled by the quadratic is? The other one, you'll hear the term, what's the horizontal distance? Okay? And the third one is, what is the initial amount? And really, what happens in all of these is we're really looking at some very basic questions from the parabolas. In this case, what is the maximum or minimum? Whenever you hear the words maximum or minimum, you need to think, find the vertex. The vertex of a parabola is always going to be the maximum value or minimum. So whenever you, in a story problem, if you hear maximum or minimum, the number one thing you have to do is find that vertex. That's going to pretty much almost always be what they're looking for. The other one that we're going to look at is what's the horizontal distance. The horizontal distance is really a fancy way of saying find the zeros. Or we also know these as the x-intercepts. So whenever they talk about the horizontal distance, a lot of times they're going to involve something very similar to finding the zeros or those x-intercepts. And again, there's modifications that can happen to the problem, which might not necessarily mean that you're finding the zeros, but it's going to be, the concept is going to be very similar to it that you're going to have to do. The other one is you'll hear this sometimes. Probably these other two, these first two here, 1 and 2 are more common, but the third one will also come into play, and that is what is the initial amount? And the initial amount is really find the y-intercept. And again, we find that y-intercept by letting x equal to 0. We go through and do that. That will give us our, that will help us solve all of our story problems that we have. And pretty much when you're working with quadratics, again, like I said, the first one and the second one are going to be the most common. And probably the first one is number 1. Second one will be a close second. Third one will also come up, but it won't be as common as the other ones. Now, this will conclude our video on this for the quadratic functions right now. We still have a couple other things a couple other examples, and really it really goes to solving quadratics and solving the story problems that we're going to be looking at in class. So we'll look at that, and then we'll work on problems from the book. The other thing is that I'm going to try something a little bit different. You notice how the desks have changed. Well, what I'm going to do is you don't need to complete a whisk on this video, and we'll probably won't do any whisks for the next chapter, for at least chapter 2, and we'll just see how I feel about it at that point. What I'm going to do is when you come in, you're just going to have, I'm going to check your notes. And I'm going to just check it off and say, okay, you got a point for your notes if your notes are complete. If they're not complete, then you won't get the point. So I'm just going to take a look at your notes, see what you have, and then we'll go from there in terms of working on problems in class. So with that, make sure you go through, make sure you're comfortable with the stuff that we've done, the stuff we've covered in this video. And we will see you in class next time.